Hello, everyone, and welcome. This is the latest Tech Talk on IEEE 802 networking standards, and today we welcome Paul Mikulich, Chair of IEEE 802 Landman Standards Committee, and David Law, Chair of IEEE 802.3 Working Group, for a discussion on the state of Ethernet. My name is Jennifer McLean. I'm Senior Manager of Education Products with IEEE Educational Activities, and I will be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable, so you can move them around to make the most out of your dashboard space. We encourage questions for today's panelists, and you can submit them through the Q&A widget on your screen or click the purple Q&A icon at the bottom of the screen, and we'll answer as many questions as time allows. If you click the green resources icon at the bottom of your screen, you'll find more information about IEEE 802 standards, past and future virtual events, and a copy of today's presentation. Finally, the on-demand link, which will include a copy of the presentation for today's Tech Talk, will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about this event, please use the hashtag IEEELearn. I will now turn it over to Paul.
Thank you, Jennifer. Welcome, everyone. We're glad to have you here. Today's talk is going to be about the Ethernet technical standards that are developed inside of IEEE 802. And we are very fortunate to have David Law, who has been the chair of the 802.3 working group that has developed the technical specifications for the past 12 years, or David has been chair for the past 12 years, and 12 years before that, the vice chair. So he is steeped in Ethernet. And he also is coming to us from Oban, Scotland. I'm in Essex Fells, New Jersey, so welcome, everyone. We're very glad to have you here. Ethernet is a set of technology standards that have developed over the past 50 years, and we strive within 802 to develop high-quality, market-relevant standards. And I just want to give you a brief, I forgot the disclaimer. Make sure that everyone understands that the views expressed here are David's and mine's alone, and not any position of the IEEE. Just briefly, here's the 802 organization that I'm fortunate to lead. Consists of about 750 people. It's broadly broken down into 3 major areas. There's the wireless component, the wireline component, which is Ethernet, and then there's a common component, which acts as the bridging layer between the two. And today's talk, as I mentioned earlier, is going to be on Ethernet. So let's get it started with a question for David. David, can you explain at a very high level what is Ethernet for our audience?
Okay, thank you, Paul, and thank you for having me. And that's a great question to start with. So often when I'm asked that question, I'll hold up an Ethernet twisted pair patch cord. I have one here, and ask everybody who thinks this is Ethernet. And actually, from the many articles I've seen in the mainstream press about the internet, and I see them illustrated with a picture of the RJ45 connector and the cable, I think many of them think actually this is the internet. But anyway, while this is the case for Ethernet to some extent 20 years ago, when it was predominantly used in the enterprise, that's changed over the years. And there are now many other application areas beyond the enterprise where the twisted pair cable with the RJ45 connector is familiar. Now, that isn't to say Ethernet doesn't still have use in the enterprise, although, of course, client connectivity these days is moving more and more to wireless. Even though that move, however, has led to an increase in demand for both throughput and power from Ethernet to support higher speed and higher density access points. But back to the question. From a technical point of view, Ethernet is a media access control, a MAC, that supports both half-duplex operation using carrier sense multiple access with collision detect, or CSMACD, which you may be familiar with. That's for shared medium half duplex access, as well as full duplex operation. And actually, full duplex operation has been the predominant mode of operation of Ethernet for many years now. And while full duplex removes the contention, the congestion from Ethernet, and it makes full duplex Ethernet effectively lossless, other than the bit error rate of the medium, this just moves the congestion point from Ethernet into the switches that are used to interconnect Ethernet links, where the aggregate bandwidth of multiple inflows directed to a single output port can oversubscribe that output port's bandwidth. But even then, our friends in 802.1, which is another 802 working group, they have a set of standards and projects under the time-sensitive networking to address that, among other items. But anyway, I digress. So 802.3 Ethernet also specifies media-independent interfaces, allows the connection of different physical layer entities, or PHYs, and then we have the PHYs themselves that support the different media. And the diagram you're seeing at the moment illustrates the plethora of media that Ethernet supports. So in this figure, as we go from left to right on the diagram, we increase in the reach.
Excuse me, David. Before you get into those details, I think it's important for us to emphasize to those people that may not be familiar with technical standards that the reason we've developed them is such that we can have multi-vendor interoperability. And the work that David's group does, when vendors follow his group specification, different vendors can operate with other different vendors. And there's as he's going to be going into now, a whole family of physical layers that these specifications allow interoperability over. So excuse me, David, for interrupting, but I just wanted to bring that point through.
And that's indeed a key point, and that's fundamentally the basis of the success of the standard is providing that interoperability, providing that multi-vendor interoperability, and providing it at a low cost. But coming back to the diagram we have here, yes. So I was saying that we're increasing the reach as we go from left to right, and the rates as we go from bottom to top. And as I noted in the diagram, any circle with a thick border is a project objective from a current 802.3 project. And as you'll see, we have a lot of projects. And not all of the projects are PHY projects, and not all of them are illustrated here. So there's certainly a lot of work going on in 802.3 on Ethernet at the moment. So quickly going across to start with, on the left, we have the very short reach AUI, the electrical interfaces, and they're an example of a media-independent interface. Electrical backplane PHYs. We then have short reach twin axial copper PHYs, single twisted pair, and 4-pair twisted pair PHYs. And then we have plastic optical fiber, multi-mode fiber, and then single-mode fiber. And even the single-mode fiber solutions are broken down further into point-to-point, and there's both duplex and bidirectional. And bidirectional is where a single fiber is used for different wavelengths in with different wavelengths in each direction. So there's just a single fiber used, as well as dense wave division multiplexing systems, DWDM systems, where the PHY supports a grid of transmit and receive wavelengths. And finally, we have Ethernet support for point-to-point, point-to-multipoint single-mode fiber with EPON, or Ethernet Passive Optical Networks. And in the future, we have another project that's currently undergoing called SuperPON. So EPON is primarily a subscriber access network. A single fiber from the central office goes to optical splitter combiner near the subscribers and provides reaches in tens of kilometers of split ratios of up to 1 to 64. That's the number of subscribers on a single EPON. And the SuperPON project seeks to build on this by using wave division multiplexing and wavelength splitter combiners to support multiple EPONs on a single fiber coming out of the central office, along with optical amplifiers to support greater reaches. And this slide just illustrates current projects. We just started an activity to consider a new project with a scope of beyond 400 gigabits per second Ethernet. And so 800 gigabits, 1 terabit and 1.6 terabits per second are all in scope for consideration in that project. So anyway, I hope that just gives you a quick overview of Ethernet and what it supports.
That's great, David. There are so many different media depicted in this slide. It's amazing what the group has been able to develop standards for. Before I move to the next slide, I just want to let everyone know we encourage you to post questions in the Q&A section. We will reserve 10 minutes at the end of the talk to answer your questions. So if you have any questions as we're going through this, please put them up in the Q&A section. So back to this slide, so many different media, David. What drives the need for so many different media?
So moving on to the next slide, you have, thank you. So what drives this is, and drives all the different data rates as well that you see, are really the different target application areas which this slide illustrates. And actually it also illustrates the dates of approval for each increase in rate, or each Ethernet rate we've developed over the years as well. So in addition to what I talked about before, I'll classify as the traditional Ethernet routes, which was the enterprise. It also targets data center, that's both with high-speed switch-to-switch and switch-to-server interconnectivity. And there's backplane, twin-axial, twisted pair also has a role in data center as well, and multimode. And also, more recently, we're seeing data center interconnect projects and the support for DWDM systems. PHYs I just mentioned are a part of that. There's then access and carrier networks addressed by long-reach optics, both point-to-point as well as the point-to-multipoint EPONs I mentioned. And the examples include the subscriber access networks and front-haul and backhaul for cell towers. That's one of the components of 5G that Ethernet is addressing. And as an aside, we also have a project to improve precision time protocol accuracy on Ethernet, and that's another example of our support for 5G radio access network infrastructure. There's then industrial control. That's a new area for Ethernet to address. The recent Ethernet standard in this area was 10 megabits per second operation over up to 10 kilometers of a single twisted pair rather than the traditional 4-pair twisted pair. And this is based on leveraging existing industrial control cabling defined by the multiple field bus standards. And that's based on a desire to enable consolidation of Ethernet, consolidation of industrial control over Ethernet. And then finally, there's automotive Ethernet. So Ethernet was first used in cars as part of the diagnostic port, and that was only active when the car was in diagnostic mode and not running. It moved on significantly since then, particularly as cars have become more akin to data centers on wheels, and they will do more in the future, do more so in the future. But I should emphasize, to me, automotive Ethernet is a little bit of a marking term and a bit of a misnomer, with applications in rail and aircraft as well as automotive. As well as single pair, the automotive Ethernet family also includes the plastic optical fiber, PHYs that I was mentioning. 1 gig operation is already specified, and there's projects underway to expand this up to 50 gigabits per second. But one thing that I would always note is it's important that a particular project may be driven by a particular application, but it's just Ethernet. It can be used anywhere. And I always say never underestimate how smart the users of a standard are, particularly if they've got a way of enabling a lower cost approach. And what I mean by that, one example is when we did 40 gigabits per second Ethernet, it was primarily targeted at server connectivity, but provided a 40 gigabit per second capable module interface. And that was widely utilized for low-cost, high-density 10 gigabits per second connectivity by what was termed breakout modules, 4 ports of 10 gigabit per second. So to some extent, 40 gigabits per second success was actually largely driven by its use as a 10 gigabits per second breakout solution. And finally, one other area to cover is the power over Ethernet along the bottom there. Its data rate is 0, it's DC. So it was initially driven by the enterprise, in the enterprise to support the move to IP telephony, and as well as wireless access points. But the power we've had 2 projects that have increased the power since the original specification was developed, and it addresses much broader set of applications now. Other areas talked about are PoE lighting, power over Ethernet lighting, and internet kiosks. Now, that power over Ethernet supported 4-pair structured cabling, but we also have standards for power over single-pair cabling called power over data lines, or PODL, which inevitably, of course, becomes POODLE. So while IoT devices will often be wireless moving forward, of course, when they do need power, they're not mobile, they need to be wired, there's a single-paired solution now that provides both data and power through Ethernet. So that might be another application area you can see Ethernet moving into. And finally, one change I want to mention that's happened over the years is the need for more targeted data rates. When we did 100 megabit, 1 gigabit and 10 gigabits per second to some extent, they probably addressed the 2 main applications at the time, enterprise and data center. But we used the rule of thumb that the core data rate has doubled every 18 months, and while the edge rate every 2 years. So even they diverged to the extent that one rate could no longer address both, as illustrated by the development of 40 gigabits per second and 100 gigabits per second at the same time in one standard. And as a result of this and the diversity of the applications Ethernet now addresses, we actually developed 6 new Ethernet rates in the last 5 years. It took 30 years to do the previous 6. And as I've already mentioned, we're already looking at beyond 400 gigabits per second.
David, this is a great slide that shows how over the past 40 years, Ethernet has evolved to meet the various needs that have emerged in the market. Question I have for you is, how does the market bring their needs to the 802.3 working group? I mean, how does the market interact with your group and enable you guys to decide what direction to take?
So we have a very broad set of participants within the 802.3 working group, and they're all affiliated with many parts of the industry. So that's how the needs are brought in with proposals for new standards. Another area that we've worked on as well is, and I think there was a previous tech talk on, is bandwidth assessments, and looking at what the various parts of the marketplace and the needs are and what's driving the increasing needs for bandwidth. And that report very much drove the activity that resulted in the recent study group, the Beyond 400 Gigabits per Second study group. So that's another example of how the needs are brought into the working group.
Yeah, that's true. And I think a couple of the other reasons that the market is able to interface with 802 well is that we are open and transparent. We welcome people to come in and make proposals, and everybody gets to share their information on an equal basis. It doesn't matter if you're a single individual in your own little startup company or you're employed by a massive company. Everybody's treated the same. So it's really a good platform for new ideas, whether they be technical or market-oriented, to come in and gather momentum and consensus. So that's one of the reasons I'm very proud of 802 for enabling that capability.
You're absolutely right, and I think we've got the links at the end for people to access the information about the 802.3 working group. All the presentations, as you say, are available. At the moment, participation is particularly easy because all our meetings are online. Even when they're face-to-face, anybody can attend. You don't have to be an IEEE member to attend. Everybody's welcome.
Yep. So that's very important. So I've got a couple other follow-on questions. How do 802.3 Ethernet and our 802.11 wireless LAN, also known as Wi-Fi, complement each other in the marketplace?
So, I think they're very complementary. As I mentioned, 802.11 wireless access points were one of the two main use cases for initial power over Ethernet development. And of course, having power over Ethernet, I will argue, made the installation of 802.11 access points easier because they generally aren't always right beside a power outlet, and being able to run the data and the power over the same cable to your access point made them easier to install. Now, of course, as I mentioned, client connectivity such as laptops are moving more and more to wireless, and of course there's an increased number of wireless clients, cell phones, tablets, and of course IoT devices as well. But that in turn has led to, as I mentioned, an increase in demand for both throughput and power to support higher speed, higher density wireless access points. So that in turn has led to the development of most recently 2.5 and 5G base T standards to provide increased connectivity, 5 gigabits per second, 2.5 gigabits per second. And another project that was certainly used that as a driver was the 4-pair power over Ethernet project to provide increased power, because some of these higher density, higher speed devices need increased power. So it's kind of a symbiotic relationship, I guess. You know, we help them, they help us. So to me, it's very complementary.
Okay, very good, David. And 802.3 and 802.11, they've been both extremely successful in the marketplace. To what do you attribute 802.3's adoption by component developers, product developers, service providers? What are some of the drivers behind that fantastic success?
So I think there's a number. And I mean, the first one I have to recognize, certainly personally, is the amazing experts from throughout the industry that I have the privilege to collaborate with, and that's very important. But as far as the standards themselves, as you mentioned already, the openness, the fact that anybody can come in, we're always welcome to ideas from anybody, and it's all on an individual basis, so it's kind of an equal basis. For the standard itself, it is providing the interoperability between competing products. Backward compatibility with the installed base is also very important, and to me, another key thing is specifying only what it needs to. And just to the last point, what I mean is the standard should not define implementations, and it shouldn't constrain implementations. Instead, it should just specify only what is required to achieve interoperability, and then leave it to the implementers, allow them to be free to decide how to meet that specification. So this, for example, enables innovation, potentially reducing costs. So as approaches to implementation not available at the time the standard was developed become available in the future, then there's nothing to constrain the implementers from using that future technology, that future implementation to reduce cost. But that isn't to say that we develop standards that can't be implemented, which kind of leads me to another factor, I believe, in our success. And it's a set of criteria that we use to measure our projects against before we start them. And the main criteria there are technical feasibility. To put it bluntly, we don't do science projects. We do something that can be implemented. Economic feasibility. There's no point doing a standard for something that is so costly nobody could deploy it. And broad market potential. Is there actually a market there for what we're proposing? So that's another key factor. And finally, I'll add another factor I believe that is important, which is sticking to our scope, which is MAC and PHY, and then working cooperatively with other SDOs and other organizations for what we don't do. And an example I'll use for that is the building wiring standards from ISO IEC to ATC1 SC25 Working Group 3. And they provided a generic cabling in buildings, a specification for that many years ago, which I believe was fundamental for the success of 10-base-T at the time, because it provided this installed base of generic cabling that we could run our application over, 10BASE-T Ethernet. Not to
Very
mention,
good, David. We've got it.
Sorry, I was going to say there's many other successful organizations, relationships, ITU and OIF. I just want to give a shout out to them too.
Okay, very good. We've got a couple of questions, good questions from our audience. This one I think is particularly good from Ali. What issues or problems are faced in capturing this technology? And what that brings up to my mind is that in 802.3, you've got all these competitors working on the same thing. And how do you deal with that? So well, that's what my thought is. But what do you think some of the issues and problems are in capturing consensus on a particular technology?
Yeah, I mean you've got a key example of some of the challenges we have, which is different proposals coming in, and how do we reach consensus? And that takes a lot of consensus building, a lot of conversations, a lot of talking. I mean, the ultimate way that I would always use to achieve consensus is, ultimately, if you're smart, you probably can implement what you're proposing, or you can implement what the other is proposing. And let's just all come to some consensus and move forward with at least one specification we all believe we can implement, and then we go out in the marketplace and we compete, and that's how we make money. Is when we all go out in the marketplace and compete with each other and sell product. And if you're going to delay it by having an argument over what approach to use, particularly if actually the approach you're arguing against you probably could implement as well, maybe it's time to move forward. So yeah, but that is the challenge, and I have to recognize the leaders in 802.3, many of them, the 802.3 task forces chairs and study group chairs who work relentlessly to build consensus and move forward.
Yeah, I think one way to summarize is that by bringing your ideas into 802 and collaborating with like-minded technologists, you're enabling a much larger marketplace. And even though your slice of the pie may be smaller, the pie itself is huge because the technology has been standardized through consensus.
But
I've got another.
That pie does not exist until you get that consensus, and that's the key.
Yep. I've got an interesting specific question from Robert. Could you comment more on work on commercial aviation diagnostics over SATCOM links? Now that really is outside the scope of 802.3, but I'd like to point out, as David mentioned, that automotive work that he's doing is also targeted at other modes of transportation, those modes being rail, aircraft, and spacecraft as well. So, we see Ethernet deployed throughout all different modes of transportation, but it's not wireless. So there are no satellite communications in Ethernet yet. Here's another question for you from Rick. What are the pros and cons of using Robert's rules versus IETF humming to measure consensus? Oh, that's a very detailed consensus question.
And that may also be controversial as well, because if I take a position on that. But obviously, I think the process we use is the best one, because that's what I'm involved in. I think the pro, and just to be clear, we are guided by Robert's rules. I think the pros, and actually I think that the key point of what of our process isn't actually really something in Robert's rules, but it's more the fact that we have a 75% requirement for technical consensus in ASO2 areas. And I think that's, once you get to 75%, it kind of gets sticky. I mean, getting to 50% approval is, yeah, you can flip either way. Once you've got to 50, you can fall back. But once you've got the level of consensus that 75% of the group agrees, it's kind of sticky. So it's more difficult to get to. That's a con, probably. But the pro to it is once you get there, it means you probably have got good, solid consensus and you can move forward.
I would say, just to give you my perspective, the fact that we can rely on a rigorous process is helpful when there's lots of contention. If there's little contention, you can run things a little more looser. But when there is contention, everybody knows that they're going to be treated fairly according to these procedures. And I think that's been very beneficial over the years. I've got another question for you from a fellow named John. I'm on the 802.3 webpage. What is the new Ethernet applications ad hoc?
So that's an opportunity for individuals that have ideas to bring them into .3 for consideration. So we have a fairly formal process for setting up a study group and then starting a project. But if you just have an idea or you want an opportunity to bring it in and see what level of interest there is, the new Ethernet applications area is where to bring the discussion in, and it's fairly low amount of work that needs to be done to get into that. Just let us know you have some area. Come and talk to myself or there's a gentleman called John D'Ambrosio who chairs the NEA, and we'll be delighted to help you as well. And come in and do a presentation and explain what your idea is. So it's certainly a way to bring in new ideas and new proposals into the 802.3 Ethernet working.
Okay, very good. We're a little bit over time, but I do want to wrap up here. But before we do, I've got a question that I think is particularly interesting for those people that are new engineers. What would you recommend to a recent college grad who wants to get involved in standards development, but is concerned about their limited work experience as compared to more seasoned professionals already working on a standard?
So first, have a look at, certainly from the 802.3 perspective and 802 in general, have a look at our website. You can have a look at the presentations, see what is there. There's also, I would suggest joining the Ethernet, sorry, the email reflectors if you want to follow the discussions that are going along, and I'll also suggest coming along and just join the meetings and listen to what's going on. And I'll just reflect my experience the first meeting I went to, and I was sitting there quietly, and that was quite a few years ago, 31 years ago, and I was sitting quietly in the corner just listening, and I'm like, this isn't right. This calculation isn't quite right. Doesn't this, get retimed, and therefore the jitter gets set back to 0? And I kind of, sheepishly went, excuse me, doesn't it get? And they were like, oh yes, you're right. So, listen to what's going on. I certainly would encourage listening to what's going on, but you'll probably find a way to contribute. And to me, it's very easy ways to contribute. Email reflectors so you can follow the discussions, and like I say, all the meetings currently are teleconferences. And even when we were doing face-to-face meetings, there was still plenty of teleconference meetings to attend as well. So just engage and listen and build your confidence that way. That's my suggestion.
Very good. Excellent advice, David. Coming from young David from 31 years ago.
Yes, I still remember that.
So, okay, well, that wraps it up for this Tech Talk. Thank you very much, everyone who's participated, and especially to those of you that have sent a few interesting questions our way. We hope you participate in future 802 Tech Talks. We'll be covering other technologies that we're developing within 802. And thank you very much, David, for giving us your time.
Thank you very much for having me.
Okay, take care, everybody. Bye.
Bye. Bye. Hi, everybody.